That we definitely will do, especially with V8 stuff. Just because you think it's this set of angles, it's always much better to validate it with a 3D print before you go and make a huge chunk of billet into something that's half a tiny little bit of a degree out, or, something shifted in your calculations. We definitely use 3D printing to validate stuff.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Darcy from Plazmaman in Australia. Plazmaman is a manufacturer of all manner of aftermarket performance parts for a wide range of vehicles. They're probably best known for their aftermarket intercoolers and their inlet manifolds, or plenums. And it's a balancing act here, as we talked to Darcy about during the interview, between form and function. And Plazmaman do an amazing job of producing a part that not only produces great power, but also looks amazing. And when you're spending your hard-earned cash on upgrade parts, we obviously really want to be able to have it all, have our cake and eat it, so to speak. As you get into this interview with Darcy, we dive deep into the world of CNC machining. You'll learn what is involved in designing and developing these parts, from the outset using 3D modeling software through to the validation of these parts using CFD, to then prototyping and actually manufacturing the parts and testing them out on the dyno to ensure that they actually do what you'd expect. We also break down some myths, and you'll find out that bigger is not always better, particularly when it comes to components such as throttle bodies. You find out what the downsides are when you go to a throttle body that's much bigger for your application than it actually needs to be, and you might be surprised to find out that most people are probably fitting throttle bodies that are much bigger than they need to be. Before we get into our interview, for those who are fresh to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to tune EFI, how to build performance engines, how to design and build wiring harnesses. We also cover topics on race driver education, race car setup, and data analysis, just to name a few. All of our courses are delivered via high-definition video modules that you can watch from anywhere in the world, provided you've got an internet connection. All of our courses also have a no questions asked 60-day money-back guarantee. So if you ever purchase a course and decide it wasn't quite what you expected, no problem, let us know and you'll get a full refund of the purchase price. If you want to find a full list of our courses, you can head to hpacademy.com/courses. And as a podcast listener, you can use the coupon code podcast75, and that will get you $75 off the purchase of your very first HPA course. I'll put a link to the coupon code and our courses page in the description. All right, let's get into our interview now. All right, welcome to the podcast. Darcy, thanks for joining us today. And as we always like to do, let's start by learning a little bit about your background. Specifically, how did you start getting interested in cars and the automotive scene?
I started getting interested in cars when I was in the second year of my machine shop apprenticeship. I've previously I couldn't tell you the difference between a Commodore and a Falcon. One of the guys in the workshop was heavily into cars. He got me into it. I went from having no learner's license, no car. I actually bought a car before I could drive it.
Okay.
And then figured out how to drive it home because I didn't know how to drive a manual car home. Drove it home, and it's been a long, interesting journey since. Didn't work in the automotive industry until, I actually crewed on a top fuel car 2 or 3 years later. Went to my first, top fuel race. Went, wow, that's pretty cool. Walked down to the pits because, I know they disassembled the car by then. Started talking to one of the pit crew guys, and he was like, yeah, you know how to do stuff on cars, which, by then I'd already replaced head gaskets and stuff on my car because, you're a 20-year-old and you buy shitbox cars and they blow up. Yeah. Doing the head gasket in your works car park with, bolts you bought from the bolt shop instead of buying actual head bolts is good, interesting. Teaches you a lot about, how fasteners can work.
Yeah, and I guess the benefit there is you get to really learn more because you'll be replacing the head gasket again real quickly.
No, I didn't have to. I bought...
Really?
Yeah, it was a BMW that I bought blown up with a blown head gasket, replaced the head gasket in the work car park, just sanded the top of the block with a parallel, sanded the head with a parallel, cut down some 12.9 bolts, put it all back together, bled it all up. Didn't know that I had to open the heater circuit to bleed up a cooling system because, I was literally just figuring out from, okay, I put it all back together. I put coolant in it, ran the car, and my mate was like, you need to open the heater tap, bro. You need to open the heater core to let it bleed up properly.
Okay, all right. Steep learning curve.
Oh, yeah. And then took the car to 2 drift days, drove it around for like 6 months. It was fine.
Nice. Okay.
But yeah, worked on a top fuel car for about a year.
And what were you doing on the top fuel car? Head gaskets, maybe?
Well, yeah, they don't really leak water out of their head gaskets. There's no water in them, obviously. I was the blower guy on the car. We'd get the blower off. I'd check through everything. Like, you'd check every single fuel line on the blower. You check the tolerances of the rotors to themselves with a feeler gauge. You'd also check how they're actually physically looking because they do run looser and looser every single pass. And we'd never re-strip the blower. Like, obviously a top fuel blower uses Teflon strips to keep it, tight.
Sealed.
Yeah, we never re-stripped it at the track, but obviously I learned how to re-strip it back at the workshop. But yeah, blower guy is basically just checking over the entire blower, checking over the hat that, nothing's come loose, nothing's damaged. Then it's ready to go back onto the car and make laps. Oh, and changing pulley sizes if we needed to change pulleys. That was my job.
All right, let's rewind because we wanted to chat to you because you're best known probably for your machining work, specifically with Plazmaman. Let's go back to how you got into that industry. And you also sort of mentioned you're already doing machining before you actually got involved with cars. So what took you down the path of becoming a machinist?
I guess I just always liked making things. Like, at the moment you could do metal shop and woodwork at high school. I was straight into that because I just wanted to do it. It was like the only subjects I was like really passionate about at school. So yeah, I did metalwork, woodwork. I actually did CAD at high school, drew up a BMX frame at high school. I just always loved making stuff. And when I turned 18, I was like, well, what am I going to do for a job? I already love doing all this machining stuff. Found a job at a university's like technical department. So we were making all kinds of stuff. Most of my apprenticeship was all spent on like manual machines, like manual mill, manual lathe, did a bit of TIG welding, and then, got into cars while I was doing that apprenticeship and still doing manual machining. Obviously, we learned a little bit of CNC stuff at TAFE, but the shop I was at didn't do a lot of CNC stuff. So,
for those outside of Australia, could you sort of give us a quick understanding of what TAFE is?
TAFE's it's like for trade schools and stuff. Plumbers, electricians, welders, hairdressers, everything go to TAFE. It's part of your 4-year apprenticeship, standard 4-year apprenticeship. You spend 3 years at TAFE doing, 1 week a month, or you're on the job learning.
All right. So where did the transition you mentioned you did a little bit with CNC, and where did you sort of transition and sort of see this is the future and get more involved down that specific pathway?
When I started at Plazmaman, obviously Plazmaman, I advertised for a position, I applied for it, got lucky and successful and got the position. And then I knew enough at TAFE, I could model something sort of program, but not really a part because, doing it once is not the same as, all by yourself 100 times.
Yeah, sure.
And then the bosses gave me the freedom to, if you want to come in on weekends, the shop's all here, make your own stuff for your car and just figure it out. And that's how, obviously I learned stuff during the day as well, every day, because the head programmer there, Matt, he'd obviously teach me anything he could, but we'd have to, we have to make stuff, I wasn't an apprentice anymore. So they weren't trying to teach me everything, but if you're keen, you could definitely soak up a lot of knowledge there. And if you're really keen, come in on the weekend and figure stuff out. And that's what I did over the years, just, come in on weekends, make stuff for my own car, make stuff for mates, and, just make stuff just to figure out how to, run a toolpath. I want to figure out how to run this toolpath, how do I do that? Let's just make some random block of something just to figure out how to run it.
Okay. We'll get more into the weeds with the specifics of what you were doing there, but let's get a bit of insight into Plazmaman. You're not working there anymore, But what was Plazmaman at the time you joined in terms of size, and how did it grow? How long were you with Plazmaman?
I started with Plazman, it's now 7 years ago, so in 2016, I think. They've always been a massive name in the Australian car scene, and obviously now they've grown internationally. They started back out in the 90s with one of the bosses, Oye. He was like one of the first guys to make performance intercoolers for cars back in the day. He'd actually get used or new diesel cores and cut them up, make them into street car size intercoolers. And that's how Plazman started. Around the 2000s, the other boss, Alex, he came on board, and that's when they started doing more and more performance car stuff and started getting into the intake manifolds as well. And when I'd come on board, they already had, a CNC department. They had 3 CNC mills and a CNC lathe, and the main programmer, Matt, who's a great guy and a great programmer, and he programs the bulk of all the Plazman parts that you see. And by the time I'd left, they had 7 CNCs, including a massive big DMG horizontal and still that 1 CNC lathe. So it'd grown quite a bit, and we'd gone from, everyone had just run the standard shift pattern, Monday to Friday, 8 till 4, to when I left, I was running the night shift, keeping everything running. Would pretty much always work a weekend day. So
you'd almost gone to sort of 24/7 for production.
It was definitely 24. Like, we'd leave at least half the machines running lights out overnight. Like, I'd finish at midnight. A program would be running for at least 3 to 4 hours on 3 or 4 of the machines. And Matt would start at 6 a.m. And so we'd get nearly 24-hour runtime on half the machines for 6 days a week.
And what sort of drove the expansion in terms of production levels? Is that just sort of more products being made with more demand, or is it breaking into, at least as far as I saw it from the outside, Plazmaman being based in New Zealand, obviously we've always known that name because the Australian-New Zealand markets are so similar. But I kind of saw, maybe I'm wrong here, but a push over maybe the last 5 or so years, maybe a bit longer, into that US market, particularly around some of the LS products. So I'm not sure if my read on that's correct, but fill us in.
It's definitely trying to push into the American market. Like, look, compare it. Australia and New Zealand combined, we'd be under 30 million people. America's 330 million.
Yeah, it's a magnitude of scale.
Yeah. Like, Texas's car market alone would be bigger than Australia and New Zealand's combined. So one state in America is bigger than our entire market share in our home countries. It's silly not to push into America. Yeah, the evolution of the CNC program at Plazman was definitely driven by the all billet V8 manifolds. Like, we started with the LS. That was very popular. Then we did the Coyote billet intake manifold. That Coyote billet intake manifold was probably the most successful product Plazman's made.
Interesting.
When we first released that manifold, we could not keep it on the shelf. Yeah, like, we'd make 20 of them, sell 20 of them. Make another 20, sell another 20.
What made it so popular? Was it just a manifold that provided massive gains? Why was the demand so high?
It worked really well. And obviously, the looks, the Mustang crowd is very, they're not as budget minded as the LS guys. Like, an LS, you can turbo an LS for $1,500. So says the internet.
Yeah.
So says the internet. You can't. Well, you can, but it's not going to live for very long. Where the Coyote market is much, they seem to be more mature, bigger spenders on, stuff like that.
Yeah, that makes sense.
And we also got very lucky in working with one particular racer, Brett Lasella, with his Mustang called Snot Rocket. And he was a very good marketing piece for us, because that car was very successful and is now incredibly successful in Snot Rocket V2, where it's, making north of 2,600 horsepower with stock crank, stock block, stock heads. Well, OEM parts, they're not a stock Mustang part, but they're I think he's running a GT500 crank, a stock actual Coyote block, and Voodoo heads, and making, north of 2,600 horsepower and running 650s in the quarter mile.
That's impressive to have any stock parts in an engine that's making those sorts of numbers, though. That's hats off to him to hold that together. Okay, let's sort of talk about the evolution of some of these parts, particularly if we look at the design of a new part that Plazmaman makes. And you've talked there about intercoolers. We obviously talked about the intake manifolds, and there is a range of parts that Plazmaman does produce. What I'm interested in to start with, what is the process on deciding on a new product or part that you're going to bring to market? How does that sort of conversation even begin?
It'll mostly begin with customer demand. Like, if enough people go, we want this, or we can see something. Obviously, we look at market trends and, new platforms that are released, new engines that are released. We'll look at those as well. When the Godzilla engine got released from Ford, we're like, look, we've got to get onto that. That'll obviously be a big platform. But yeah, like the amount of parts that we want to make is near limitless. It's just, finding the time to prototype and R&D a complete new part, and also keep up with the production of just, the parts that we already sell. But yeah, it's looking at trends and also what people ask for. Between the boss, myself, as I ran the Instagram as well, the sales team, and everyone else, we're all like, people have been asking for, a 4G63 manifold with 3 injectors. We go, if, 30 people have asked for that, it might be worthwhile looking down that path.
Yeah. I guess with that sort of stuff as well, some of the more niche stuff, like a 3-injector inlet manifold, just for that example, as you brought it up. I mean, obviously that's only going to really be suitable for someone drag racing on methanol, where the fuel demands are massive, and for a street guy, probably easily get away with 1 set of injectors, maybe at a stretch 2 staged. Do you sort of try and design the parts so that you can use the same base part and set it up as a 1-injector, a 2-injector, or a 3-injector manifold, just to save, rather than trying to make multiple versions of the same part?
You definitely have to be smart on the design side of stuff, so you can have some universal-ish parts. If you're familiar with Plazmaman's manifolds, you'll know that all the fuel rails look relatively the same. All the fuel rail stands are either 2 style of designs, where it's either a leg type with a spacer and a leg, or if it's just a straight rail, like just a straight spacer. Like, yeah, you have to try and keep some parts at least universal in either theory and practice. So, you're not making a completely new program. Well, you are making a completely new program, but a completely changed program for every part, because the stock levels is insane. Keeping stock of everything that you need for a full billet manifold is, a full-time job all in itself.
Oh, I can imagine. Just while you've brought up the sort of multiple injector setup, just a question that keeps coming up when we post anything about our Plazmaman SR20 VE inlet manifold. Now, that uses 2 injectors per cylinder. And I wouldn't say it's unique to Plazmaman, but the design of that is that the injectors are side by side. Whereas conventionally, I think it would probably be more common that for a 2-injector inlet manifold, you would actually have separate rails and the 2 injectors sort of one behind each other in the runner. The way Plazmaman have done this, I think, makes a lot of sense because it simplifies things. You've only got the single fuel rail, so the installation of that, the plumbing is dramatically simplified. So now I've kind of explained how that's done. We don't have the aid of pictures for a podcast, of course, but hopefully everyone's sort of picking up what I'm putting down here. The question is around having 1 injector, essentially, it's obviously a 2-valve inlet in the cylinder head. You've kind of got the injectors offset, one in front of each inlet valve, I guess, if you like to sort of think it like that. And the question we've had is, do you have distribution problems of the fuel when you've only got 1 injector running, maybe at lower RPM where you're only using the primary injector? It's obviously not central in the port. It's going to favour the fuel delivery more towards one side of the port. I've not seen any issues in our SR20 around this, but I'm interested, is this a consideration or is it just a non-issue?
It's definitely a consideration. Like, obviously, when you're switching on both the injectors, it is better for everything because, well, hopefully you're spraying a pretty even amount out of both injectors. Depends on how you choose to set up your fuel injector setup. But most of the time, we've found that if you're below the point where you're switching on both injectors, you're not going to be running your boost maps and timing maps that hard that the slight advantage to one side of the valves is going to be any kind of problem.
Yeah, that makes sense. I mean, I think our use is probably pretty typical of that style anyway, in that kind of pretty much exactly what you're saying there. As soon as we've got any substantial boost in RPM on board, I've got both injectors operating at equal pulse widths. So we're just optimizing or maximizing the fuel availability, at which point obviously everything goes out the window. I think also worth mentioning there, a little off our topic, but I think people get a little too infatuated with the injector design or location. The reality is, with a port injected engine, a lot of that fuel is going to wet out against the port wall, and once everything's up to operating temperature, it's going to be spraying against a closed intake valve at least some portion of the engine cycle, and therefore it vaporizes off that hot surface and actually introduces the fuel in a vapor format, which is better for combustion anyway. So again, a little off topic, but I just wanted to sort of get that in there. Now, I do want to come back to the inlet manifolds in a little bit more detail, but before we do that, just in terms of general product design development, what software are you using for modeling these parts?
We're a big supporter of Mastercam. We've always used Mastercam software to model all that stuff. Now that the business has grown so large, we used to draw everything physically in-house at the factory. Now we use a guy that we always use, like he's basically part of Plazmaman, but he's an outside contractor. I think he uses SolidWorks for his actual modeling, but anytime it's inside the factory, like if I have to draw a flange or something, or even something relatively complex, it's not a full intake manifold, we'll always just use the Mastercam drawing software.
Is there advantages and disadvantages with the different pieces of software, or does it come down to just personal familiarity and personal preference between the different products that are out there? I mean, from my perspective, and I am absolutely not a CAD user, we've got our own CAD course that Connor's just recently released, so I've got a broad understanding of it, but it seems like you can, for the most part, get the same results across multiple different platforms.
On the drawing side of it, they definitely are. I don't think Mastercam has the rendering abilities of, say, a SolidWorks, where some people make those really nice, fancy, full car renders and stuff. Don't think Mastercam would probably be able to do that. But for the essential purposes of, this is the part I want to draw, they're all relatively the same. Besides some of the more organic sort of shapes, you might run into some problems with some softwares, but for the drawing side of it, they all seem to be relatively much of a muchness for what a CNC machinist wants, where they just want a model. They don't need a fancy render.
I think the other thing, and again, this is from my understanding of discussing this in depth with Connor, is people get quite fixated about a particular software package, and I think the reality is that if you have learned on let's say Fusion 360, you can probably, with a relatively minor amount of retraining, kind of apply what you already know to SolidWorks or maybe Mastercam for that example that you're using there as well. So there's a lot of transferable skills, I think, once you actually understand the process of modeling and design. It doesn't really matter which platform you're specifically working on. Does that sort of would you agree with that?
Definitely. It's all, you're all making a square with a round and stuff. Like, it's just figuring out where, all the different tabs are on the software is. I relate it much to tuners, just jumping between ECU packages. You're all doing the same thing. It's just the screens look slightly different.
Yeah, it's actually a really good comparison. The basis is the same, but the user interface might look a little different. Shortcut hotkeys probably also a little bit different, but again, relatively quick and easy to relearn those. In terms of making these parts, I think particularly in the last decade or so, we've seen a drive to not just produce a part that does a job. It's equally important that the part looks great doing it. The balance of form and function has really become much more important, and we've seen a lot of companies like Plazmaman and your competitors that have really put a focus into the aesthetics of the part, whereas maybe 15 years ago when I was running my old shop, that wasn't the case, and you didn't have the choice, and a lot of the parts did the job, but you wouldn't be proud to pop the bonnet and actually show it off. How at Plazmaman did you sort of balance that form and function?
at our point, they're both equally as important. Like, it has to perform because, no one's going to spend $4,000 on an intake manifold that does worse than stock. But we have to put time and effort into making it look nice, because when you're spending $4,000, you don't want it to just perform nicely. And look, I'll say it, I'd say at least half the customers are buying it for the looks. If you've got a 2J, everyone knows what the stock, most people know what the stock 2J intake manifold looks like. It's not a pretty thing. If you've spent big money on your big shiny precision turbo and $40,000 on an engine, you're not going to want to run the ugly stock intake manifold.
No, absolutely. I think that has just become a much more important focus for people, is buying parts that they're proud of, that they really fits with the aesthetic of the rest of a build as well. And can't take away from that. But as you say, I mean, the performance has to be there as well, I think.
Yeah, it's definitely, they're both equally as valuable. Like, we definitely lost a lot of sleep machining tool paths and stuff to make them look nice and make them look. Anyone that's looked at all the Plazmaman billet manifolds, they all have an aesthetic that's all very similar. Like, they all look like a Plazmaman manifold.
Yeah, it's definitely a family resemblance there for sure. Moving into sort of the validation of the parts before you actually go into producing a prototype even. What's done there, if anything? I mean, are you using CFD to help design the likes of an inlet manifold to try and optimize flow? Or is this a kind of by eye thing? Is there any finite element analysis in terms of making sure a part is going to be fit for purpose in terms of the stress that it's likely to be seeing in operation?
Yeah, Alex, one of the owners of Plazmaman, he has a lot of racing experience, and Plazmaman has worked with a lot of racing teams. So they start out with, we've got these theories that we have worked for 10, 15, 20 years on race cars. Then we will take it through CFD to make sure, that the plenum design that we're making, that if, say, it's into a retro car, the dome that's been cut down a little bit isn't going to, lean out cylinder 6 if it's a 6-cylinder manifold. So we definitely have to check it in CFD because, just what you think is going to work isn't always going to work, and changes do have to be made to stuff. The runner design was always pretty, they've found a certain set of taper angles and, top to bottom opening on the runners that works, like a ratio that works very well. And so it's just the theories and principles that they've built over the last 20 years. And it also definitely gets run through CFD to make sure there's no surprises with what we make. You can't go, we think this is going to work. You have to run it through something and go, hey, this is going to work.
Yeah, I guess it's going to be a lot cheaper to do that in the virtual world than machining the part as a prototype and then finding out either on the dyno or maybe on a flow bench that there is a glaring problem that's been overlooked. On that basis, is a flow bench a useful tool for validation once you've actually got a physical part, or as it goes sort of straight to a trusted partner that puts something on the dyno and actually does the validation on the dyno?
It's a lot easier. Well, not easier. It's a lot better to do the validation on a dyno because you're going to find out, the part physically fits as the final thing. And obviously flow bench data, everyone knows that, you can manipulate that. And it's not the be all. Flow bench data is not the be all and end all of how an engine runs. We'd much rather have it validated on a dyno any day of the week.
Yeah, I mean, I guess the dyno ultimately is the final sort of the number that you want to see. What's it actually done in terms of power and the torque curve? Where have you gained? Where maybe have you lost? So that's the ultimate. The other element, though, that can be a little bit tricky in terms of just putting things on a dyno like that is if you do have an airflow distribution problem, can be a little bit tricky to sort of highlight. With a conventional engine, you're probably going to have a single lambda sensor, either post-turbocharger or post-collector on a naturally aspirated engine. So you're kind of just getting a sample of the average of all 4, 6 or 8 cylinders, which can mean that you could have 1 or maybe 2 cylinders that are a little lean, but if you've got a couple that are then a little bit richer, your actual average air fuel ratio is still kind of on point. What I'm getting at is that can hide some of the potential flow distribution problems unless you go into the trouble of individual cylinder lambda or individual cylinder EGT. So for your test pieces, you go into the trouble of that sort of data analysis?
Yeah, most of the time we'll either have someone that's, they've got their big block Chev that's set up with individual EGTs anyway, or if we want to test on the dyno and we want individual EGTs, obviously we have a full welding, Plazmaman has a full welding department. It's very easy for us to go, hey man, just come in, we'll put EGTs on the car, it won't cost us that much because it's pretty easy for one of our fabricators to put some EGTs on a car, go down the road to get Haltech, as anyone that's gone to Plazman and Haltech knows they're basically next door to each other. Go down to Haltech, grab some EGTs, and wire it into their ECU for us to, properly validate that, every single cylinder is running with a good balance of airflow distribution.
Yep, yep. In terms of sort of proving the fit of the component, obviously modern engine bays get incredibly tight. And what are you using there in terms of making sure that a plenum design, an inlet manifold design that you're designing in Mastercam or SolidWorks or whatever it is going to clear all of the other engine bay components? Is there any 3D scanning going on there so you can actually build the manifold inside of the engine bay virtually?
Not really, as everyone knows, every engine gets thrown into every single car nowadays. We'll definitely, check it on the cylinder head, check that it fits to the factory cylinder head with no issues. And with some cars, we'll offer a cut down dome. But it comes down to the compromise of, do you want the performance or do you want your car to work like an OEM car? We can't give you everything.
Yeah, there's always got to be some compromise along the way for sure. And I mean, yeah, if you're talking about an engine swap, then I guess all bets are off. It'd be nice, obviously, if you're making an inlet manifold for a 4G63, that it will, for the most part, clear all of the factory engine bay components in a 4G63. But yeah, once you start putting that into maybe a Datsun 1200 or something, yeah, all bets are off.
Yeah, with the older JDM stuff, you can basically eyeball and use a tape measure and use a ruler. You don't have to go to the massive expense of, getting someone out, 3D scanning an engine bay and then digitizing all that. You can figure it all out in your head. And that's what we'd do. We'd just go, look, the strut tower is this far away from the face of the cylinder head. Let's just not make it that big.
Yeah. Yeah. So that sort of gives you the hard limit that you can basically work within.
Yeah. Unless you're doing something like a B, like the new Supra, where just stuff is everywhere, most cars you can figure it out with simple tools. You don't have to go to that massive expense of a 3D scan of an engine bay to figure out stuff that anyone that's done this for long enough can figure out with a tape measure, a ruler, and half an hour of just nutting it out.
Yeah, okay. In terms of prototyping, just along the lines of proving fitment and maybe sort of getting a proper idea visually of how everything's going to look, do you ever 3D print a sample, not necessarily for actually running and dyno testing, but just for physical fitment purposes?
That we definitely will do, especially with V8 stuff. They've got the V in them, most of them. Just because you think it's this set of angles, it's always much better to validate it with a 3D print before you go and make a huge chunk of billet into something that's half a tiny little bit of a degree out, or, something shifted in your calculations. We definitely use 3D printing to validate stuff, especially stuff with rocker covers and stuff. So you can, you don't have to cut a rocker cover in half anymore. You can just go, look, this is what's going to clear with your shaft mount rockers for your LS. Or, yeah, 3D printing for the price of it is a very, very valuable tool to use to validate, just, okay, it fits, 100% fits. I don't have to carve a big bit of billet out.
Obviously, if you're going to start with a piece of billet, the expense is going to be significant just for a test piece, correct?
Definitely. Oh, and it's not even the cost of the billet, it's the cost of the time. And, if you have to make a jig for something, yeah, it's a huge amount of cost where, you can spend $100 for 3D printing something and go, yep, I know it fits roughly, as 3D prints aren't super accurate. Well, they can be, and just go, yep, it fits. Now I can cut my big bit of billet, make my jigs, and be assured that it's not going to rub or misfit somewhere.
Let's talk a little bit about the process of taking the final design from a 3D model and actually getting that into a CNC mill for the machining processes. And I think most people who are fresh to this would think it's simply a case of sending your file from Fusion 360 into your CNC mill, and out pops your finished part, and there's actually a bit more to it. So can you talk us through what is actually involved and how that is done at Plazmaman?
Okay, so we'll get the 3D model or draw the 3D model ourselves. Then you start with I'll set out all my levels so I, can separate everything so I don't have a bazillion lines going all over the screen. And then you start, you have to know how to machine, like the theory of machining to start doing it. You're not going to finally engrave it from this, as the first tool path. You've got to take all your material, all the bulky material out with your software, and then, go through your finishing tool paths, any drilling operations, all that kind of stuff, and just think about how it has to be made and what's the most efficient way of making it. There is a million ways to skin a cat in machining, but you've got to find the way that works best for you.
So is this a purely a manual task of creating these tool paths, or is the software that sort of does a lot of the heavy lifting for you? What's involved?
You have to pick the tool path. It will generate the code itself, and some of them will generate the look of the tool path by themselves, especially with more of the adaptive or dynamic roughing tool paths. They're hugely beneficial because you can go, I've got an island block and then I've got a weird shaped bit of stock, and you can just select the stock, select what you don't want to cut out or what you do want to cut out, and it will figure out the rest. But you do have to select every single tool path yourself, set the tool path up with, its correct speeds, feeds, step overs. You can get them to be preset, but they will change nearly every single time you use them in some way, shape or form, because every single setup is nearly unique. You'll have a bit of material that's stuck out way further, or you can't grip it on very much, or it's bolted to a jig that's really secure, so you can really dig into it with a tool.
Okay. I'm guessing there, you just mentioned digging into it, so roughing the part out, obviously there's a lot of material that's going to end up being removed. I'm guessing in a lot of instances you're going to end up removing more material than you're actually left with. So the process there, obviously the faster you remove the material, I say obviously, but I'm assuming the faster you remove the material, that's going to have an impact on the finished look of it. So is it a case of sort of a roughing operation to quickly remove the bulk of the material, and then going in with a finer tool path that's removing less material to get sort of the finished look that you want on the part?
Oh, definitely. Like, you can, if you really want to, run just the roughing tool path, but it will look very obviously like you've just run a roughing tool path. Like Plazmaman, we chucked out, in a billet manifold, we would be chucking out 80% of the material into a scrap bin for it to get recycled.
Fortunately, it can be recycled. Very wasteful otherwise.
Oh, yeah. So, yeah, definitely we're roughing out as efficiently as possible. We didn't rough as hard as you possibly could because, you don't want to have something break. It's better to run a production part 10 times with no breakages and lose 10 minutes out of a cycle time rather than break a tool, which then breaks the part, or it destroys the part, and then you lose time there. So yeah, we're definitely running roughing tool paths. Some of our parts would even run like a semi-finishing tool path and then go to the fine ball nose finish that gives it the distinctive Plazmaman look.
Sure. Obviously, the time spent machining is totally dependent on the part that is being produced. But I mean, could you give us some idea of the time? Let's say maybe one of your billet inlet manifolds for an LS would be a pretty well-known part. What sort of time does that actually take to produce?
Because like the billet V8 manifolds are all in many, many parts, there's like 10 individual parts in them. We never actually got a total time for all the parts. But say a set of runners for the billet manifold, for the LS billet manifolds, just the runners would be a 4-hour cycle time to make one runner. And say for the...
Yeah, it's not a short process.
No, it is definitely not.
In terms of some of your plenum chambers are full billet, and then others have sort of a sheet metal plenum itself with billet flanges and billet runners. What's the process of the sheet metal component on those inlet manifolds? How are those produced?
They're produced with hydroforming. We have our own dies and stamps and a press in-house. One of the owners, Oye, has developed all that himself, figuring out, this is how much slip the die has to have, this is how much depth it needs to have the crush and stuff. We're sort of a bit tight-lipped about that because we've obviously developed some very, very strong domes that have, to my knowledge, we've never had someone crack a dome or break a dome. So we try and keep, our secrets under wraps with, how we're doing that. But it is just,
yeah, that's understandable.
It is pressing and forming. It's just, there's a lot more to it than just that, obviously. We'll make our own dies in-house and the forms that they go into, and then they're cut and welded together and welded onto the plenums with our amazing welders.
The welds are a thing of beauty. It looks like you've got a robot doing that, but it is actually all done by hand. So credit to whoever is hanging off that TIG, because their work is second to none. I'm interested, aluminium as a material is known for potential cracks and failures as a result of cracking. How do you sort of prevent that with your plenum designs, particularly these fabricated components where they're actually welded together?
It's definitely choosing the right material grades. They're not your standard run-of-the-mill aluminium grades in those plenum domes. And we do a couple of processes of annealing them to make sure that they're flexible enough to form to the dies. But that annealing process also helps with the cracking. And it's also, how they're welded, the prep on the weld, the amperage and how they're welded to get the right penetration and stuff to them so they won't crack. And, leaving the right kind of chamfers and stuff on it so you can get the penetration on them as well.
Sure. From what I understand, lifetime guarantee on these components through Plazmaman anyway?
Lifetime guarantee for sure. We once tested our dome to over 700 PSI of pressure. While it definitely bubbled the dome out, as you'd expect with 700 PSI of pressure in it, it did not leak at all and did not crack.
All right. So that should cover anyone in the drag racing scene for eternity, I'd imagine. I can't see anyone producing numbers that are going to really push that beyond its limit.
No. Yeah, I think the pro import guys are up to 120 PSI at the moment, so they've got a while before they start giving it any run for its money. To my knowledge, we've never had a comeback on a plenum cracking or leaking.
All right, so suffice to say, the processes that you're going through, the materials you're using are absolutely working.
Definitely.
All right, let's get a little bit more into detail with the plenum inlet manifold designs. It's obviously there's going to be a variety of differences here depending on the base vehicle you're dealing with, but are there any generalities around where the sort of limitations or bottlenecks are with a stock inlet manifold? Like what do you have to overcome in order to be able to produce a good gain in power with your aftermarket unit?
Well, the OEM stuff is more obviously they'll make more power, but the Plazmaman, any kind of aftermarket intake manifold, is more of just moving the power band to somewhere that's more favorable for anyone that enjoys their hotted up street car and enjoys their racing. Obviously, everyone knows the OEM manifolds, they're very good for, your low end torque, but most of the time, if you've got an RB26 that you can run to 9,500 RPM, you're going to see the dyno graph fall over up in the top, where if you put a Plazmaman intake manifold on it, it will keep climbing in the correct direction, and it won't have that rollover effect that a longer runner and a smaller plenum volume that the OEMs usually tend to go with happen.
I mean, obviously the OEMs are going to always favor low RPM response and peak torque at lower RPM, and I mean everything changes, particularly with a turbocharged vehicle. As soon as you take that factory turbo and throw it away and put on something that's able to flow, let's say, twice as much air, generally that's always going to move the sort of peak power and peak torque higher in the RPM range, and that gets outside of the realms of what that factory inlet manifold is really designed to do. So no kind of rocket science involved with that. I think most people could probably figure that out. In doing this, is the sort of, you're going to have to give something away though to get that gain at sort of 9,500 RPM. Does that absolutely mean that we're going to lose some of the bottom end or all of the bottom end performance?
You're definitely not going to lose all the bottom end. Like, we would never try and design something that guts your bottom end, because obviously a customer's going to get in their car, and if it's gutless in the bottom end and they've just changed your intake manifold, they're not going to be happy. But we do definitely prioritize, where the engine has its intended use. Like, people will put one of our billet LS manifolds on and go, oh, it doesn't, doesn't make more bottom end torque. And we'll have to go, hey man, like, this is not made for bottom end torque. Like, it's not a street style manifold. It's for, high performance cars and racing. Like, it's designed to work at big boost levels, big RPM, but we're obviously paying enough attention to not absolutely gut out the bottom end either.
At least as I sort of understand it, a lot of the manifold design comes down to the runner size and runner length. And I think the general sort of rule of thumb is that a longer inlet runner tends to sort of move your peak torque lower in the RPM range. And if you're building something that's designed for very high RPM performance, you tend to move towards a shorter runner. It's very, very general, that concept I just mentioned. In saying this, though, where I'm going with this, obviously there is going to be a compromise there somewhere along the lines. And like you're just saying, you don't want to destroy the bottom end and focus everything on the top end. Do you have any sort of rules of thumb for runner lengths and diameters, or is it a case of actually validating a number of different runner lengths before you finalize on what you're going to do for a production part?
Alex, the boss, he definitely has his theories and principles on, the bottom port size to the top port size, and keeping that to a certain ratio, and keeping the taper of the actual runner to a certain taper, as well as the bell mouth to a certain size radius. A lot of the time, you're more constricted with, especially V8 stuff, in what you can physically manufacture and bonnet clearance and the cost of something. If you make a inlet runner 4 inches longer, you've got to buy a 4-inch longer bit of billet. But we definitely have played around with different lengths and styles of runners, and we've just found a certain set of principles and ratios that work. And obviously we validate it every single time with CFD and the dyno, but it mostly doesn't change a lot, because an intake port is an intake port. It doesn't matter if it's on an LS, a Cody, or a 2J. They're all an internal combustion engine, and they all want the same kind of airflow through them.
Yeah, that makes sense. I guess with maybe the inline 4 and 6 cylinder stuff as well, it's going to be a little bit easier because they're a modular design. You could actually try different runner lengths with the same plenum body during that validation process.
Yeah, definitely. We could. We have tried different lengths on like a 2J. We've had someone on the dyno, we've made 2 different manifolds and gone, this works, this doesn't. We'd mainly change it with like the bell mouth length, because that'll give you the artificially longer runner, even though the manifold physically doesn't look any longer. And we shortened them up a little bit and found them, it still doesn't destroy the bottom end. It didn't make the bottom end any worse, and we found it didn't roll over as soon with that a little bit shorter runner. So we sort of favor a little bit shorter a runner. It just seems to be what we've found works best.
All right. Well, same sort of question there in terms of rules of thumb for plenum volume. I mean, physically, you look at a Plazmaman inlet manifold, and the volume of the plenum itself is obviously going to be significantly larger than a factory plenum. Where's the balance there, the pros and cons of going larger versus smaller in that plenum capacity?
It's definitely dependent on, with V8 stuff, the cubic capacity of your engine and your turbocharger size, which is why you don't actually notice it sometimes, but we do actually have options of plenum volume for stuff. And for stuff like if you compare the plenum on a single injector 2J to a 12 injector 2J, the plenum is actually quite significantly bigger, as we're assuming if you're running a 12 injector 2J Z manifold, you're not going to be running a small frame turbo and making low boost.
Yeah, you're probably not in the 600 horsepower vicinity anymore.
No. Yeah, so we do actually change plenum volumes, sort of to suit what a person will want. If you've got a six injector manifold, we'll make the plenum dome a little bit smaller, like the plenum actual base plate a little bit smaller, so it has less volume. And when you step into a 12 injector manifold, we'll make it bigger. to suit what we assume most people are buying a 12 injector manifold for.
Yeah, that makes sense.
And we definitely have the choice in like the LS7 and some of our full billet manifolds. You can opt for a larger plenum volume. So if you're running, a 427 with, a pair of twin 88s, you can go, yeah, look, I'm going to need more plenum volume. I want more plenum volume because I'm just pushing so much air in there.
Yeah, okay. Bringing it back more to sort of a modified, fairly healthy modified street application. And I mean, this probably is a bit of a how long is a piece of string question, but to get some concept out there for what someone could expect from just a inlet manifold upgrade and nothing else. So let's say we've got I'm going to come back to 4G63 because I like 4G63. So let's say we've got a reasonably healthy 4G63 with a built engine and a decent turbo setup, and maybe that's sort of punching out maybe sort of 600, maybe 700 horsepower to the wheels. And you go from that factory inlet manifold to a Plazmaman. What could we expect in terms of gains and maybe losses if there are any through the rev range?
If you've got a 600 to 700 horsepower Evo, you'd probably be gaining anywhere between 30 and 50 horsepower because you're going to be able to RPM it more, and you're not going to lose anything out of your bottom end. It's just not your curve before it hits boost and higher RPM isn't going to change. Where people will buy those manifolds and be like, I just want it to make power everywhere. I don't know what you expect out of stuff, but it's not magic. It's not going to just make everything better.
No, absolutely. And I think most people are probably able to understand that. From my own experience, and sadly this was actually a competitor's product, so I won't name this, but back through my old shop we did this with a customer's Evo 8 drag car, and I can't remember, I think we got up to about maybe 700 wheel horsepower on the stock inlet manifold. And we went to an aftermarket manifold. That one actually did lose a very small amount of bottom end, but it was irrelevant because it was a drag car. But what it picked up in the top end was huge. I think we're in the vicinity of about another 45 kilowatts, I think it was. But more importantly, you were talking about this before, that the power curve would significantly roll over. Obviously, the factory rev limit on the 4G63 is intended to be about 7,500 RPM. At that time, we were running this thing to about 9, which isn't crazy, but the thing would actually just completely fall over. And with this bigger plenum inlet manifold on it, it would hold right out to 9,000 RPM. It was only just starting to fall away, and that's why, particularly out sort of 8.5, 9,000 RPM, that's why there was such a massive gain in that power. So really easy to sell it to someone when you can see the before and after dyno plots like that. More often than not, these products, in my experience, and end up being part of a complete build, so it's really hard to then hit the dyno and go, oh, what did I gain from the head porting versus the cams versus the turbocharger versus my inlet manifold? And the answer is no one knows because you didn't test each part individually. So yeah, it's nice just to get a perspective on what that one part is going to do, because of course it is quite a reasonable investment, isn't it?
Oh, definitely. It is actually quite hard to get a direct back-to-back from someone that, people will go, oh, it's your mate's buddies, blah, 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 you just, bumped up the dyno feed. It's very hard to get a non-partial back-to-back where they've only changed one component in something.
Yeah, definitely. I think the other thing is because none of us are really sort of set up with a budget to do all of this testing in stages, which obviously would be the ideal and scientific way of proving what an individual part does. Almost always when we hit the dyno, we've changed maybe 2, 3 or 5 different components. So you're hoping that the combination has all moved you in the right direction, but when it does, it's very hard to apportion X amount of horsepower gain for that one part. I just wanted to take a moment out from our interview with Darcy here and talk about a course that, if you're enjoying this interview, is going to be super relevant to you, and that is our 3D modeling and CAD for motorsport course. This is a technology that has become increasingly easy to get hold of these days, particularly with the likes of Fusion 360 offering essentially free use for home enthusiasts. It has never been easier and cheaper to design high quality parts. But of course, in order to do this, you need to understand how to use the software to get the most out of it. That is where this course comes in. We cover all of the general tools that you're going to need to understand and master in order to draw 2D and 3D parts. You'll also learn how to use aspects such as the sheet metal tools in Fusion 360. And while I've used the term Fusion 360 here, really these skills are interchangeable between the different platforms. So if you're personally preferring to use the likes of SolidWorks, everything within this course will still be 100% applicable. As well as this, we cover some of the design considerations from an engineering standpoint that you'll need to understand when you are designing and making parts for a motorsport application. Obviously, if you design a part that's really not fit for purpose, this could result in a failure, which could either damage your vehicle or potentially even risk injury or death. Obviously, this is something no one wants to occur. So having an understanding of the engineering fundamentals is absolutely critical. There's also a simple step-by-step process included in this course that you can follow through when you're designing and making your own 3D models. The course also includes a library of worked examples where you can watch the step-by-step process being applied in a real job where Connor goes through designing and developing parts for various applications. As a special deal, you can use the coupon code Plazmaman50 and that'll get you 50% off the purchase of this course. We still offer our no questions asked 60-day money-back guarantee, so if you purchase and for any reason at all decide it's not quite what you expected, let us know and you'll get a full refund of the purchase price. Let's get back into our interview with Darcy now. Let's move off the topic of inlet manifolds a little bit, and just as important as the inlet manifold, of course, is the throttle body. And I wanted to talk about this because I've discussed this with, I think it might have actually been Alex at Plazmaman years and years ago, and he's quite passionate about the topic of throttle body sizing. I think generally out there in the industry, and this goes for almost all car parts, there's this mentality of bigger is better. And if you apply that to throttle bodies, that's not always going to be the case. I'm interested, what can you tell us about throttle body sizing? What do we need to keep in mind?
Plazman's very passionate about it. Like Alex, one of the owners, is very passionate about it. And that's gone through the entire company because we will often talk people down a throttle body size because it's just not, it's going to make the car lazy. Like if you've got 1,000 horsepower 2JZ, you do not need like an 85 or bigger throttle body, where we'll be talking people out of an 85 millimeter throttle body all day and trying to get them into a 76 millimeter all the time because it'll just make the car lazier on like driving around because it's got such a big throttle body on it that, you know, the moment it cracks open, it's going to start wanting to, you know, eat up air and all that kind of stuff. And they just make them lazy. Where most street car guys, they could go down a throttle body size, lose absolutely no horsepower, and get a more responsive car that day.
Yeah, I think this just all comes from sort of, unfortunately, seeing car builds on the internet and, you know, everything just tends to go bigger and bigger.
If you're chasing just a peak horsepower number on the dyno, the bigger throttle body is never going to show up as, you know, a hindrance. But if you, if you're driving it, and especially if, you know, you are circuit racing it, you have to have the correctly sized throttle body, or it's going to be not as responsive, and it's just not going to drive as well if you had the appropriately sized throttle body on it.
I think the other element that comes into this is really just for a street car or a circuit car, it's the ability to modulate the throttle that's so important. And when you've got such a big throttle body, an oversized throttle body, what I think people also miss is that the airflow through a throttle body is really, really non-linear. So if we could sort of plot it, you kind of end up with this massive gain in flow or increase in flow from completely closed throttle as you first crack it, and then quite often you'll see that from 80% to 100% throttle opening, if you do 2 runs on the dyno at 80% and then 100% throttle, in a lot of instances there'll be little to absolutely no change. So yeah, that airflow is sort of a reverse exponential curve. So the bigger the throttle body, the harder it is to modulate that throttle in very small openings from close. That's sort of what you're getting at there?
Oh, definitely. Like if you've got a street car with an 85 millimeter throttle body on it, the moment it's at 30% TPS, you're getting a lot of air through that engine. It's a huge amount of air that you don't need in a car that's a street car. Like it's just, it's not going to handle or drive like you want it to. We've definitely had people go from someone else's billet manifold or a street car manifold that they've chopped up with, a big throttle body. We'll talk them into they'll want to buy our product and we'll talk them down a throttle body size. And then they'll call us back like, oh, wow, the car drives like so much nicer because it doesn't have this huge, ginormous throttle body on the front of it. Just going, I want a heap of air at 30% or 40% TPS.
So how hard is that conversation? I'm assuming that you get sick to death of bashing your head against a wall, having the same conversation over and over again with people that they don't need the throttle body that they think they need.
Fortunately, our sales team, because, our reputation and brand is so powerful, we can go, look, man, you don't need this throttle body. For the amount of power you want to make, this is what you need. And most of the time people are, oh, okay, you guys are the experts. I'll go with that. So it's not usually a hugely hard hill to overcome, but it's definitely something where you have to go, hey man, like how much horsepower are you actually planning on making? Like, do you really need, we'll look at an order sometimes and be like, hey man, do you really need a 102 throttle body on your 1000 horsepower 2J? You don't. You're not trying to make north of 1800 horsepower, man.
Yeah. I mean, I think the sizing of components like that throttle body, it sort of almost comes to the same as sizing of turbochargers. I see this time and time again, people going with a turbocharger that's bigger than they need for their power aims for a start. Maybe they're being a little unrealistic and a little optimistic with what they think their actual power aims are going to be. And so you end up with this turbocharger that you're really not using its potential. You're not using the airflow it's capable of producing. And all you end up doing is making your engine less responsive, laggier than it could be if you actually size the turbo for a realistic power aim. And the same comes with the throttle bodies. Now, obviously, it sounds like people purchasing Plazmaman product can be guided on this through the sales team, which is great. I'm just wondering, do you kind of have any rough guidelines on like for X 100 horsepower, this throttle body sizing is where you want to be and how that steps up? Can you give us any sort of insight there?
Yeah, like on your 4 to 6 cylinder stuff, like obviously V8 stuff, you're basically restricted to a 90 mil. That's the smallest they come with. But if you've got a 4 to 6 cylinder car and you're making between 6 to 700 horsepower is your aim, you only need a 66 millimeter throttle body. If you're trying to make 1000 horsepower, it's a 76 mil, like a 3-inch or 76 mil throttle body. If you're making, between 1000 to 1400, it'll be an 85. Yeah, I think it's an 85 that we sell. And then anything over that, you can either go to a 92 mil or a 102. Like when you're in that over a 1500 horsepower mark, you're sort of getting out of the this is a nice car to drive anymore.
I imagine at that point the throttle modulation really could just be an on-off switch. You're not really too worried about the throttle modulation as you come out of a corner, because that sort of application is probably only driving in a straight line for 400 meters and that's about it.
Yeah, if you're managing to use 1400 horsepower effectively on a circuit, yeah, you've got a very interesting build there. If you can modulate.
Well, having said that, the power figures for the likes of Time Attack, World Time Attack in particular, do continue to spiral out of control every year we go over. So you can never say never.
I think even on the World Time Attack guys, they're probably very on-off switch on their throttle. I don't think those engines are sort of making any sort of mid-range power to usable.
Yeah, absolutely. I don't know if you can give any feedback on this, but something I've always wondered about specifically, this is a very particular engine, which is Nissan's RB26, and in stock form that comes with 6 individual throttle bodies right up near the inlet port. I'm going to guess that the designers there went that route with the intention of aiding throttle response. Then obviously anyone in the RB world who's going down the path of a semi-serious build is going to go with a single throttle plenum chamber instead. Have you ever done any comparison or seen any comparison data between the ITB setup in stock form and going to a properly sized single throttle body? Are the downsides in the throttle response, or is this kind of smoke and mirrors?
Look, the engineers at Nissan actually did a really good job on just the RB26 plenum. It's a very well-designed plenum. It's appropriately sized until you get to about the 900,000 horsepower mark. So most of the time, by the time people are seriously dyno testing a 1,000 horsepower car and then chucking it out for a Plazmaman, they're not super concerned at like the small margins of drivability that they're missing or maybe missing isn't really that noticeable to them anymore, because once you're in a 1,000 horsepower car,
it comes back to that sort of fit for purpose. I mean, it's probably not the throttle response is probably not the main criteria at that point, correct?
No, that's the problem. Like by the time that most guys are chucking out the stock plenum, they're already in a very serious super responsive car anyway.
Yeah, no, that makes sense. All right, let's move on. Next topic I wanted to talk about is intercoolers, and you kind of mentioned that Plazmaman sort of got the start on doing intercoolers. Obviously, that whole market has changed massively. And is this in one of those areas where bigger is in fact better when you're sizing up an intercooler for your project, or does it still come down to appropriate rules of thumb in terms of sizing versus power requirements?
It is an appropriate rule of thumb, but given how everyone that's been paying attention to the aftermarket industry has watched how incredible turbocharger technology has gotten in the past 8 or so years, and we're pretty much now at the point where buy the biggest possible intercooler you can afford and shove into your car, and that will be what's going to work for you.
Right, so no real downsides.
Unless you're running like a 2-litre SR20 with like a 600, 300, 100, but there's no real downsides to going bigger with your intercooler.
Okay.
It's more about the frontal area that we try and get into a car rather than the actual depth of the intercooler.
In terms of base intercooler design, there's sort of 2 different styles of intercoolers, tube and fin and bar and plate. And again, unfortunately, we don't have the benefit of pretty pictures in a podcast, but if people don't understand those terms, I'm sure they can Google them. Can you give us your sort of take on pros and cons of those 2 and why Plazmaman have gone the way that they have?
Well, Plazmaman use primarily tube and fin. Tube and fin it basically uses a hollow tube to, make the structure of the intercooler, where bar and plate uses literally a solid metal bar. So bar and plate, they're obviously a lot heavier. They're somewhat stronger depending on how you braze them all together. And they're definitely better at soaking up initial heat. If if you don't have a heap of airflow going through it, they will literally just work like a heat sink.
You've got a bigger thermal mass because the intercooler physically is heavier. There's more aluminium.
Heavier. Yeah, basically. But we are much more in preference of using a tube and fin, correctly made tube and fin core that Plazmaman gets specifically made for us in Europe. Well, all our cores made in Europe, and we have a lot of them. Where the tube and fin, when it has correct amount of airflow over it, will cool just as well, if not better, and it will recover and be a lot lighter. Like you can pick up one of our 2,000 horsepower intercoolers and you can actually pick it up. It's not a 40 kilo lead weight on the front of your car.
Yeah. In terms of that initial heat soak, with the bar and plate, would that make it maybe a viable option for the likes of drag racing, where you've got that sort of relatively brief hit down the strip and then it doesn't really matter, the car's not going to probably run for another 45 minutes to an hour? Or is tube and fin still, in your opinion, a superior option anyway?
It's a superior option anyway. Like, it'll function just as well, if not better sometimes, but you're also not penalized. Like, if you're a drag racer and you're not caring about how much your car weighs, drag racing's it's really an equation. It's how much horsepower you've got and how much your car weighs. So if you can cut 20 kilos out of your car with an intercooler, that's the way to go.
Yeah, definitely. Now, another element that I think is often overlooked with intercooler design, because you don't generally see it, is what's actually going on inside those passes through the intercooler. I got stung with this with a customer's car years and years and years ago. This was a generic, I guess, Chinese or Taiwanese 600 by 300 intercooler, and physically they all looked the same. And we had this one car on the dyno. It was a Subaru WRX and would not make anywhere near the power that it should have been making, and the inlet air temperatures were absolutely through the roof. We were seeing 65 degrees C and running maybe 20 psi of boost, which just it doesn't stack up. Shouldn't have been anywhere near there. And anyway, a very long story short, what we actually found was the manufacturer of these intercoolers had changed their design, and rather than having internal fins through the passes, they were absolutely completely empty. You could see straight through them, no internal fins whatsoever. So you were just getting no heat transfer. And we swapped in exactly the same dimension core with internal fins, and all of a sudden the thing picked up, probably 50, 60 kilowatts. The air temperatures were about 10 degrees above ambient. You're like, yeah, okay, we're where we should be. Sort of what is important about that internal fins? Is it a case of more is better, or is it a balance? Because I guess the more internal fins you get as well, there's going to introduce pressure drop across the core. So again, compromise and balancing act here.
It's definitely a compromise and balancing act. Like, I bet with that one that was really hot, you had absolutely no pressure drop in that car.
Oh no, it was good. It was good. If that was the only metric you cared about, you could not beat that intercooler. Oh, you could probably beat it with a straight pipe. That'd be about it.
Yeah, straight pipe might have nearly worked better. Yeah, there's definitely a delicate balance, because obviously some people will measure both pre and post intercooler and go, hey, I'm losing 5 psi. I'm like, well, you have to scrub that air to get it to drop temperature somehow, and you're going to lose pressure there. Like,
there's no free lunch.
Yeah, there is no free lunch in thermodynamics. It has to be very carefully balanced between not getting a huge amount of pressure drop and also making a blockage in the core, because, if you're running a big turbo car, making a lot of horsepower, you don't want it to be blocking up through the core, but you also want it to be cooling efficiently. So it's definitely a very, very delicate balancing act between, having the right amount of fins and not having too many that you're getting significant pressure drop in a core.
Could you give us an idea of what would be, in your opinion, an acceptable amount of pressure drop? Let's say we've got something that's running in the 30 psi vicinity. Are we sort of expecting to see a pressure drop of maybe 1 to 2 psi, or is it greater than that?
Anything over 5 psi, it's just unacceptable. We do actually have a couple of specific cores for like the centrifugally blown V8 stuff, where they'll have slightly less cooling efficiency, but they won't lose as much pressure drop, because obviously those are very, the boost is the boost with a centrifugal blower.
You can't tweak the wastegate and get another couple of pound out of it to make up for the pressure drop.
Yeah, and those guys are quite, demanding on, I do not want any pressure drop. I will take, we can offer them, you're either going to have a better cooling or less pressure drop. And we've found it's actually a little bit more advantageous to have a little bit more boost into it and, have a couple of degrees higher temperature, rather than, like, you're always going to have some pressure drop. And if you're running 80 psi, you might have 10 psi of pressure drop, because you're just trying to shove that much air through a core that you're going to be losing some pressure.
Yep, that makes sense. In terms of the design of the end tanks as well, this is something that has played on my mind in the past, and I have seen various attempts at improving the situation. So if we take a generic sort of 600 by 300 by 76 mil core. Typically, we're going to see those end tanks designed with the inlet and outlet at the same end of the tank, or the top of the tank or the bottom of the tank, obviously depending which way you've got the intercooler around. On face value, I would sort of assume that there's a bias towards the air flowing through where the inlet and outlet are, and maybe not migrating all the way to the top of the intercooler. So what I'm getting at here is, does this introduce sort of uneven flow through the intercooler? And more specifically, are we then not properly utilizing the top third or top half of the intercooler core for cooling? The knock-on effect there, or the next question obviously comes in, is the benefit of sort of adding guide vanes into the end tanks to actually help even the flow out across the core.
You're definitely not using the top part of your core as much or as efficiently as it could be. We definitely try and make sure that we have a big, nice radius on the bottom. I don't know how you talk about the orientation of it, but so the airflow is directed towards the top of the core, because we want to use as much of that frontal area as we can, as efficiently as we can. But we've never tested it, and I've only seen 2 or 3 people ever put vanes in it to redirect airflow, but I believe there probably would be some benefit to that.
It makes sense in my mind that it would. Obviously adds to the complexity though.
Oh, hugely. That's definitely why Plazmaman doesn't ever use a stepped core, because the top stepped area of a core, that's basically never ever going to get enough airflow through it to be efficient. That's why people ask us, can you do a stepped core for, some cars? And we're just like, look, it's just not worth the time or the money making a stepped core intercooler, because you're just not, that stepped area is just not getting used. But it's definitely something we try and make our intercooler end tanks to use as much of the core as we possibly can shove the airflow through.
All right, what can we expect? What's coming up in the future? Any insights you can give us on some top secret projects that Plazmaman are working on? Any products that are nearing release that you can share with us? What's on the chopping block next?
Alex the owners are very tight-lipped about stuff that we are prototyping before it actually gets released, as it'll just, for us, it'll create undue, people will be asking. So I can't really give any secrets away, unfortunately.
Nah, fair enough. Yeah, that makes sense. No one wants the phone ringing. When's this product going to be released?
It's basically exactly that. We get enough of those, when is my intercooler actually going to be made? So, we don't need people asking about parts that aren't even available.
Yeah, no, that's fair enough. All right, Darcy, we'll get towards wrapping this thing up, and we've got the same 3 questions we ask all of our guests. The first of those is, what's next in the future for you? And to be clear, just to reiterate, you have moved on from Plazmaman. So, yeah, what's next for you?
I'm going to be starting a new job making supercharger kits soon, but always just, pushing my abilities in making stuff for CNCs and making more cool billet parts.
So more of the same, just in a different company.
Yeah, I'd like to get into making like cylinder heads and blocks, because I see them as the next, sort of big thing, especially the cylinder head side of stuff for billet heads. But, that's a one day down the track thing.
You've sort of seen in the last probably 5 or 6 years an explosion in the use of billet blocks, particularly in the import drag racing scene. The other element here as well is obviously some of these popular engines that are now maybe getting on towards 30 odd years old. You can no longer buy factory castings brand new from the manufacturers. So when the stock of parts starts to run dry, aftermarket billet probably just becomes about the only sensible option, other than the fact, of course, it gives you the flexibility to design in superior flowing port shapes and fix all the inherent problems that every OE part naturally has. So I guess it's a sensible direction to go down for sure. Next question, Darcy, is there any advice you'd give to a younger version of yourself, one of our listeners maybe, to help reach where you are in your career today a little bit faster?
Just try and self-learn as much as you possibly can, Download your Fusion 360, figure that out, at home, because everyone can use Fusion 360 at home. The cost to entry is not, I don't think it's out of anyone's reach at, $90 a month. And just put as much time as you can into stuff, because CNC is a lot about repetition. It's, knowing how it all works and then just doing it again and again and again and again. It's all about the, number of hours you put into the craft.
Yeah, I mean, the old story is 10,000 hours to become an expert in any given field, and I guess CNC is absolutely no different.
And just being like keen to do stuff. Like, if someone says, oh, I'm looking for someone to make this, jump on that. Even if you don't think you can make it, go to someone, I might not be able to make it, but I'll give it my best shot and try your hardest and, do new things.
So don't be scared to step out of your comfort zone and sort of stretch your abilities a little bit.
Definitely not. Like, obviously be honest about people, that, you might not be able to like get it as pretty as, what they're imagining, but definitely be very keen to just do stuff, because that's how I've gotten where I've gotten today, is just being keen to, try new things, do new things, and just give it my all.
Yeah, absolutely. All right, Darcy, our last question for today. If people want to follow you and see what you're up to, how are they best to do so?
That'd be just on my Instagram. The Instagram handle is bigger CNC guy, and yeah, that's about the only place you'll find me.
Cool. And if people want to follow Plazmaman, where are they best to go and do that?
Yeah, that'd be on our Instagram, Plazmaman Racing, on Facebook and YouTube. Definitely get onto their YouTube channel, because they're trying to put up some really cool stuff with builds and stuff using customer cars.
Perfect. As usual, we'll put links to all of those social media accounts in the show notes to make it super easy for people to find. Look, great to chat today, Darcy. Really appreciate your time and getting some more insight into what goes into designing and manufacturing some beautiful billet CNC parts.
All right, cool. Thank you very much, Andre.
If you enjoyed this episode of Tune In with Darcy, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Finn Photos from the United States, who has said, new favourite podcast. This has quickly become my favourite podcast. It provides in-depth technical information that I've been wishing other automotive related podcasts would dig into. Great guests and great questions from the interviewer. Well, thanks for your kind words there. Great to hear that you're enjoying the podcast. And if you can get in touch with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school, and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.